And the problem with interviews like this is it's very hard to figure out what to cut out and to keep it down, because it's all pretty good stuff.
Well, just cut out every time you're talking. That's not a problem.
There you go. That's a good start.
I thought that was already being done.
Well, that's what he usually does. Yeah.
Welcome to proglangcast. We have a special guest today. This is an interview. I'm Christopher Augustus, one of the hosts.
I'm Steve Thames.
And here is our special guest.
Hi, I'm Marshall Lochbaum.
It's great to have you here. Introduce yourself, give your own bio.
Yeah, so I have a long background in array programming. I started programming in J just a little over 15 years ago. And so that was how I got kind of familiar with the whole style. And that was my main programming language for 10 years or so. During that time, I also started working with Dyalog Limited, who are the makers of Dyalog APL. Got introduced to APL that way. At the time I was leaving Dyalog, we had done some work at the company on, what we would fix about APL if we wanted to, because it's such an old language, what we would change about it. Out of those discussions, I sort of took that on when I left because it was the thing that I had to work on. And that ended up being BQN, which is a, simplified, redesigned, reimagined APL. And so that's the, I guess, main language that I'm known for now. And also, as part of working on BQN, me and the co-creator, I guess, Zyma, who is the implementer of CBQN, the main C implementation, we built this other programming language called Singeli. The original idea was to be able to work with vector instructions well, but it's kind of moved past that into being like a system for metaprogramming. It fills the same low-level role as C, but it's designed to be much more comfortable for programming. And I guess I'll jump and do the history backwards and say before that, I worked on a language called I, which was kind of looking into more tacit programming and some more functional aspects of J. And that was my first language. So that makes Singeli the third real serious programming language that I've worked on. And that brings us to today. So that's me.
You're quite prolific in creating things, complete things. It's impressive. You can at least say you have 3 fully functional languages.
Serious languages that have all been used by at least one other person. I has not been used very much.
What got you started in programming at all? Has this been your kind of life dream to create programming languages?
Not since I was young. I was really much more interested in math when I was in middle school and high school. It was a teacher at my high school, Henry Rich, who those in the J community will certainly know by now. He knew me from when I'd done math competitions because he organized a lot of that and offered to do kind of a one-on-one study course to learn programming in his preferred language, which was J. So I took him up on that, and that's how I started J programming. It's just been a big part of my life. I wrote in college, I had this system, J to LaTeX, which is like a compiler that outputs LaTeX, but the input is LaTeX, but you have escapes for where you use J code instead. So it'll convert all the J arithmetic into math formatting. So you can do formulas that way. If you have, a bunch of different things and you want to sum them, you can do a J sum, and then the plus will be done sort of, you might say, symbolically. And the reduction will be done actually programmatically. So then you get the output. You can perform the steps and get the output as a nice mathematical formula. So that was one of my big projects in college with J programming. And by the time I got out of college, I thought to myself, what would the dream job be, as the question goes? And my answer was I would like to implement programming languages like I was doing with I. And at some point, I remembered that when I was at the J conferences a few years before, Morten Kromberg and Jay Fode, who before the conferences I didn't know, but they'd come and give some presentations on Dyalog APL. So I remembered, this company at least exists, and I checked their website, and lo and behold, a few months before, they'd put up an opening for a programming language implementer.
Wow.
That's pretty nice.
I knew that Roger Hui worked there then, and I was kind of familiar with him from the J community, so I emailed him, and I don't remember what I asked, actually, but I asked something about this job opening, and he said, well, yeah, apply to them, and I'll put in the good word, and I applied and interviewed and all, and so that's where I ended up working for the next few years.
I think his good word probably counted for a lot, right?
Well, I think I would have made it in anyway. I mean, they didn't have a ton of applicants. They certainly had nobody with experience in implementing array programming languages apply to that.
So Dialogue, though, is based in what, Denmark and London?
Their England office is not in London. It's in this little tiny town, but Basingstoke is the smallish city that's next to it. So that's where I lived when I worked there.
So you were at Dialog until 2020?
Yeah, that's right.
If you don't mind, let's rewind a little bit. What is that like doing math competitions? Your school's team against another school's team?
They're team-based and individual competitions, many different formats. Basically, it's always just, a list of problems and you solve them and you see who does the best. For fun, there was in middle school a tournament that I went to, I don't remember which one, had kind of a live format where some people would be up on stage and be asked the questions and have to get the answer as fast as they could, just one-on-one. It's like the problems in math class, but much harder and competitive. So there are some that are you just have to get a number that they want. The AIME is the highest level I got to in high school. That's kind of the qualifier for the International Math Olympiad. There's another level between the International Math Olympiad and that.
Wow.
Yeah, but that's the big high school level competitions. I did the AIME, and that's like 10 problems, and you have to put in a number. I think it's 15 problems, actually. Get like 8 or so, you're good. In maybe 6 hours total.
That sounds pretty hard.
It's hard.
There's any of those particular competitions that you think is particularly meaningful?
I was on the state team with the best people, at least the best people who would join the team from around the state. And it was really interesting working with that whole group. You get to know a lot of the kind of culture of how people try to learn this stuff. And a lot of it is, specific tricks. Some of them are not actually useful for serious mathematics, but they show up a lot in competitions. Other is just like, better ways of working on things and so on. And a lot of interesting personalities, of course.
Do you still have the same kind of interest in math that you used to have, or has programming to some degree replaced that? What do you get out of the two different things?
They blend together some. Maybe I never really had a serious interest in research level mathematics where, you really have to invest in one field and spend like months on a problem. I wouldn't say I really had that level of dedication. I felt better when I was getting a broader understanding of a field and still working deeply on some problems, but never to quite that degree. I'd like to talk some about Singeli, and so that kind of connects to it. That has a lot of similar problems. So one thing I just figured out is how to transpose a matrix where one of the dimensions is a small odd length. It's complicated to think about. The main struggle there was just, figuring out how to conceptualize the problem and, well, I'm not sure if that's the best way to put it, but how to visualize what the structures involved are, I guess. So whichever side has a small dimension, I think the easier one to think about is if it has a small width. So you've got a long, narrow table and you want to transpose the elements. And then what you want to do is read like the first some number of vectors from that table directly. And then each vector is going to include multiple rows. So they'll all be staggered at weird offsets. And then what you want to do is rearrange the elements so that then each vector that you get out is a column of the original matrix. So you're trying to do this weird permutation, and you've got a limited set of operations to do it. It's the same kind of mathematical thinking goes into that. So in that way, I think a lot of what I got out of mathematics, I do get out of programming now. And I still occasionally read math papers and stuff, which is the more theoretical aspect of math that doesn't come up in competitions. But for the most part, I'm doing the same sort of work that I enjoyed with math, but it's applicable to a different field. And I mean, neither one of these are the same as progressing the state of mathematics. I hope I'm progressing the state of programming a little. So it's kind of nice that the sort of work I like to do is actually a better fit.
Yeah, I'm going to agree with that. Do you feel that Singeli is using more of your mathematical strengths than BQN was?
In terms of designing the language, you've got the reciprocal relationship, right? Because Singeli is implemented in BQN and BQN is implemented in Singeli. So I spend my time either writing Singeli and thinking about the design of BQN or writing BQN and thinking about the design of Singeli. So in terms of those four things, the most mathematical, I would probably say writing BQN is still the most able to be mathematical, but the problems I have in implementing Singeli are not, it's not even implemented in an array programming manner. It's actually implemented with an object-oriented style, and that's much more traditional programming. And then, yeah, using Singeli is probably the next most mathematical thing.
This is probably going to sound a little stupid because when it comes to functional programming, I consider myself stupid at this point. I just don't grasp it well enough yet.
That's a very good stance to have, you know. No matter how smart or how stupid you are, it will serve you well to realize that you're at least a little bit stupid.
Yeah. I'm reading your Singeli page, and it talks about how it's written in BQN and then with a front end that emits IR and a back end that converts it to C. Is it a metastructure where you're using languages to work other languages?
The motive for making Singeli I can describe pretty concretely, and I'll try to get in a little bit about what actually is this language so we're not standing on air, maybe. When you're implementing in the style that Dyalog APL in particular is done, and probably most other APL implementations, when you're implementing primitives in this language, you need to write a whole lot of different functions, different implementations of primitives. For transpose, for example, you need to have transpose on 1-byte elements, transpose on 2-byte elements, on 4-byte elements, and on 8-byte elements. For other things, you might even have more variations. Sometimes you have 2 arguments that might have different types, and you want to have various ways of handling that. So the big thing is you want to be able to do this without either rewriting your code, copy pasting a bunch, or having structures that get in the way of what you're writing. So a lot of stuff at Dyalog was written with C macros. Roger Hui does a lot of this.
Preprocessor macros.
Yeah. The big problem with the preprocessor is that the level that you're working at is on the tokens of source code. The tokens of source code have nothing to do with the elements of arrays. You're so far away from what you actually want to work on. And so you spend a lot of time having to struggle against not having a real programming model for these macros.
Right.
Some other stuff, which is somewhat easier to do, is written with C++ templates. But these are also not really designed for this, particularly for the arithmetic. I did a whole system with this. What you have is like a template that takes a type. For simple stuff, I used templated functions, but for this, I had to use templated classes because they have slightly more functionality. But so there's a class that takes a type, it's got some functions, and then these functions can use a templated class of that type, or in some cases, they need another type, like you might need the half-width type or the double-width type. And then it gets really complicated because in order to connect to these other classes, you're basically programming with templates. You're doing compile time programming, but you have this template system, which was not at all designed to handle this. It's just designed to say, well, I've got this function and this type. It's designed to be, more of a macro-like replacement system. But what I found with Singeli was that actually it's a subset of a very reasonable system where you have a real programming language at compile time that you use. And in Singeli, this is a pure functional array language. The pure functional aspect is actually pretty much the same as C++ or various other languages that have templates. And the array aspect is a matter of implementing the operations so that they work on compile time arrays of things.
When you say pure function, do you mean pure as in no side effects?
Yeah, no state and it's not entirely true for both good reasons and bad reasons. One reason why it's not actually pure functional programming is that you write the program for its side effect, which is that it produces a program that you then compile. So the whole computation that you're specifying is a side effect of the functional program. In this meta language, when you write a plus b, that is a pure function that takes 2 values. They might be constants or they might be registers, and produces a new temporary register. But at runtime, once you compile that down, the side effect of that is to produce an addition instruction that may be implemented in several ways. Plus is not built into the language. So, but if you have the include file that defines plus, then that implements it, and it implements it with a side effect. The one built in that actually does anything is emit. So it tells you to emit a plus, and this goes through to the C backend eventually, and C writes a plus. And then that's compiled to this stateful thing that adds 2 values and puts that value into the result.
Doesn't it seem like that definition of purity or lack of purity would make all functional programs not pure? Because ultimately, at some point, even though the entire program could take a lot of inputs and produce an output, that output has to go and affect something somewhere, like generated instructions or a new document or something like that.
The difference is that every step of this functional programming is emitting its own side effects. So in a lot of functional programs, you say, I have this input, I do all this stuff, I get this output, and then you only care about the final output. I mean, really, you can model this as a pure functional subset of the whole world. The world is, of course, not very pure, but you have this little part of it that you've made pure, and you're going to pass your thing in and pass your thing out, and then you might do stateful things with it. But that part, at least, is a pure function. As the program runs, all these pluses and minuses, whatever, they evaluate their emit things, and this will eventually go into the IR. So there's this kind of log of what's happened in the program execution. At the end, this all gets output that is your compiled program, but you can't see what instructions you have emitted or anything like that.
You can write a function in Singeli, and from the point of view of the Singeli code, that's a pure function.
Yeah.
Produces an output. It doesn't change anything, doesn't change any state. But the process of emission might therefore produce something based on whatever its implementation is that may or may not be pure.
Well, it's definitely not pure. If you stripped out all of this emitting stuff, the program would still run the same way. There is a subset of it that's running a pure functional code. However, you've attached this emitting mechanism to it that records these side effects and produces your output program. You can write a program that doesn't emit anything, or it doesn't define any functions or any of the stuff that would produce output code. And then it actually is a pure functional, array scripting-ish language. And you can do useful computations with this, like you can take an array, add one, reverse it, whatever. You can compute values in this way. And this is actually really useful if your code is going to have some precompiled constant that you want. Of course, you'd rather not write out this specific constant. You'd rather write how it's derived. Then you get to use a pretty reasonable array programming system to write this sort of thing. If something changes, well, you can generate different constants that can adapt to whatever compile time conditions you have. And also it documents, how did I get this constant, as opposed to the thing you often see in C, which is this crazy array here. And maybe there's a comment above saying how it was derived, and maybe there isn't. This is much more comfortable to work with in the long term.
It's kind of the idea of comp time, right? Where instead of, like you say, hard coding a constant, the formula for which that constant would be derived, but there's no runtime cost because the compilation step is essentially doing the calculation for you.
Singeli is very similar to Zig's comp time. And actually, it's more similar than it appears, because what Zig's comp time is pretending to do is to unify this compiled time language with the runtime language. But this is harder to do than Zig is willing to commit to in terms of language complication. One big difference is that Zig's comp time is actually dynamically typed. Nominally, the values have types attached to them, but it's not run in a way where it's compiled and all the types are worked out and then it runs. Instead, if you have something that never runs or that never is involved in compilation, then it doesn't get type checked.
Oh, interesting.
Pretty much the definition of dynamic typing. If you don't reach a computation, it doesn't matter whether it's correctly typed or not.
Right.
There's a lot of languages that are trying to unify this compile time metaprogramming with the runtime. From either direction, actually. You have Lisps and other functional programming languages, a lot that are based on type theory, are trying to make their runtime programming run at compile time as well. And then you get all sorts of complicated stuff like dependent typing. You have sort of paradoxes like, what is the type of type? And it can actually be type.
Right.
And so that introduces all sorts of mathematical difficulties. Zig and I think Odin and some other languages are trying to let you run the runtime language at compile time. But that also doesn't seem that great because, firstly, the reason why you would want to program in a low-level language is for performance, and at compile time, it really doesn't matter very much. You're probably not doing complicated stuff. You're only doing it once. It would help you to work at a much higher level like you can in Singeli with tuples and stuff. So you have all these dynamically sized arrays that you can just program with without thinking how they're allocated and so on. It has that problem, and also the static typing problem where the compile time language and the runtime language are not actually the same, and you're going to get some pretty weird things as you try to unify them. So Singeli just says, well, no, these are different things. Programming at runtime has totally different constraints, different desires than what you do at compile time. So it's actually good for them to be a completely different language.
You obviously look at a lot of other languages.
Not in extreme depth. And I tend to just use my own languages for programming unless I'm forced to, for some reason, use something else.
That is really such a privilege.
It's very nice.
So you've mentioned Zig. You've probably looked at Rust.
Yes.
How it deals with its static typing and memory management.
Yeah, well, the memory management I just throw out the door, right? There's no safety in Singeli. The memory model is that memory is a bunch of bytes and you can read sections from it using the instructions that the CPU provides, and it's up to you to do that correctly. In CBQN, most of the stuff that we do is just like linear iterations, where it's very clear when you read the code that it's a loop of the appropriate length. Like it's a single loop. No, it's not going to do any out of bounds reads. I mean, maybe if you had a sophisticated compiler, you could prove that to the compiler and it would eliminate the bounds check. But the other fundamental thing is getting the wrong answer is worse than having the program crash. The most important thing is getting the right answer, and that's actually more important than memory safety.
You'd rather have the system crash than give you an answer that is incorrect because of things like bounds checking and memory checking.
It's a weird argument I'm making because you can't actually trade off one for another.
But it's not a weird argument to me.
Philosophy of Erlang, it's the philosophy of a few languages that they would agree with you. Let's crash if something's not going to perform correctly, right?
The issue is neither Singeli or Rust is going to be able to crash instead of giving you the wrong answer. If you've written the wrong thing, they'll just give you the wrong result because they don't know what you're trying to do, which is true, of course, of any language.
Is there any language that's an exception to that? Not LLM programming is definitely not an exception. It's happy to give you lots of wrong answers.
Write your program in one language and also another language and compare them and see if they're the same.
There are the proof languages, though, right? Like Agda and stuff like that.
Yeah, well, this is similar to what I'm saying because you can prove that your program matches your constraints that you specified, but you also don't know that your constraints that you specified are correct.
Right.
Having that redundancy, specifying the program as an algorithm and as a set of constraints, hugely reduces the chance that you're going to get it wrong. But it's also so difficult that no one really does it. I don't want to write it off entirely, but it is not something I've attempted for Singeli because it's just too hard to attempt, and it's, as far as I know, too hard to really use for this sort of development. When you're using Singeli, you have to ensure, through carefully considering your code and through testing it, that you're going to get the right result as best as you can. Something that automatically guarantees that you have memory safety or some other constraint, that's really not helping very much compared to that. So if it adds complication to the code, especially if it slows down the code, I mean, we want the fastest possible code because we're going to write this once and it's going to be run millions, billions of times.
And that's your main goal for Singeli is performance, right?
Yeah.
Have you seen any other use cases that you envision for Singeli outside of optimizing BQ and execution?
Well, so I think the concept of having a metaprogramming layer above the regular programming layer could be applied to other things, but you need to have the regular programming layer to be restricted in some way for that to make any sense. Otherwise, you just make a nice functional language where you can do anything you want, and that's the language you want to program in, and there's no reason to want to metaprogram that. I guess that's sort of disputed. All the Lisp programmers keep saying that macros are the greatest thing ever, and I just don't believe it. You should be doing your work at the semantic level, and functional programming works great for that.
You're right. I just try to think in what I need to do in terms of functions. Okay, I can define a function for this and a function for that and seem to do the job.
It's what I think of as one of these features for people who, rather than finding interest in the problem they're trying to solve, find interest in the code they're using to solve it. Of course, it's not wrong to think about your programming languages and how you use them. But if you think exclusively about your programming languages and how you use them, that's what I feel leads you to things like thinking Lisp macros are the most powerful it can possibly be. But that's because they let you spend more time thinking about your programming language, not because they lead you to better solutions to programming problems.
When we look back at the history of languages, they've been written for a particular purpose. In some cases, it's been educational. In some cases, it's been mathematical. In some cases, it's been for interpreting databases. There's always been some specific point behind the development of a language. Was APL written specifically for manipulating arrays?
Well, it was, but I mean, that's a little bit like saying Fortran was written for manipulating numbers.
Yeah.
I guess it's stopping your abstraction too early. The arrays are just another tool. I mean, you might as well say the APL keyboard is a tool for manipulating APL. It's correct in the direct sense, but your ultimate intention should not be to manipulate APL source code. You should at least hope to run it at some point.
Yeah, of course. Don't focus on a particular language. Focus on the problem, and then pick the language that's best suited to the problem of the languages you have available.
Yeah, well, no programming language is ever going to prevent you from writing the solution once you understand the solution. They might make it easier to think about how you solve the problem. They might make it easier once you've written the code to solve this problem, to maintain the code, to modify it in certain ways, to distribute it to people or whatever. But I mean, fundamentally, if you understand the problem that you're working with and you get what programming is, which surprisingly few people are able to do.
From your perspective, what is programming?
I just mean if you understand a procedure, being able to clearly specify the steps to perform it, which sounds so dumb. I don't know what it is, but most people just aren't programmers. They can perform the thing, they can explain to someone else how to do the thing, but they can't write it rigorously. That's the skill you need to be able to program anything. If you have that skill and you understand what you're trying to do, then it may be tedious, it may be a matter of a lot of typing, but any programming language is going to let you write the program that you want to.
All you need is a tape and a type head. Yeah, a Turing machine.
Oh, yeah, probably.
The problem comes first.
You kind of generalize the idea of what is a rigorous understanding of the problem, and you know that once you think in those terms, you can encode it in any programming language.
Yeah, that makes sense.
I think everybody's tried to write their own language, at some point. And that's not me. I haven't tried to do it. I'm curious as to how that happened for you.
I started on I within maybe 3 or 4 years. So it was like 2 years before I started thinking about writing programming languages. I try to see the connections between problems and see the common kind of mechanisms that allow you to approach those better. So the reason I started I as a serious language instead of just random experiments was that I had realized that J's forks in tacit programming and its automatic mapping over arrays are the same in some sense. In functional programming, you have these functors, which are kind of things that can be mapped over, and they're both instances of functors. Well, they're applicative functors. They have this shared structure, and then I generalizes the shared structure to other things. Well, or in theory it does. I'm not sure there's anything else useful that it generalizes it to, but that was kind of the idea that I was using with that. I would say I try to find the core concepts that cut things down to the bare minimum, that expresses the ideas that you want when you're working with something.
It sounds like you're very motivated by minimalism.
One way I think about this is directness. Having the least complication in your path from concepts that are generally useful to a specific thing that you want to express or, proof you want to do or whatever. Having your programs be most closely connected to core concepts that you understand. Not necessarily just that they're small in description, but that they don't involve a lot of adaptation to the core things that you use for thinking.
You want to have a strong intellectual challenge.
No, I would say I want to have a medium intellectual challenge. I would much rather work with the kind of medium things that become easy once you find the right way to approach them. And then it's a matter of finding the right approaches that make lots of things easy, as opposed to just having one lifelong, really hard thing that you're just struggling against forever.
You're searching for better ways to solve problems.
Yeah. At the first level, there are many problems that I try to solve. And then as I'm doing this, I think, well, is this problem related to another problem? If there's a hint of a connection, I want to explore that and find, is there really a fundamental reason why they connect? And then does that connection lead you deeper into some concept that is kind of sitting underneath everything?
Do you recall what the challenge you were trying to solve was when you came up with the idea of working on Singeli?
The closest to a specific thing was this whole arithmetic system in Dyalog that used the template metaprogramming as currently implemented in C++ is clearly just not up to this. So I wanted a system to be able to do general programming with the templates in a reasonable way, as opposed to, contorting everything to get into this template model where everything is instantiating a template. So there's hardly any difference between Singeli's model and this. At least once you understand Singeli, it feels like all it's doing is lifting restrictions, which is not entirely true. I mean, it introduces a whole lot of other programming concepts, but fundamentally, the Singeli model is to say a template that takes some parameters is really just a function that's running at compile time. To avoid confusion, these are called generators in Singeli. You can define any generator you want, and it's all dynamic. You can just say def generator of these parameters equals whatever. And I mean, this is not really any different from declaring a templated class, except that in the frame of functional programming, none of these restrictions that C++ has would even occur to you. So you get a much nicer system. Then we introduce features from functional programming Big one is having this match structure, which is similar to, switch or
Pattern matching.
pattern matching. At compile time, you have this type and this length and whatever, and then you write a match statement that matches on the type and gets you whatever thing you want. Maybe in some cases that returns a number, and in some cases that returns a type, and it's all fine because you can sort it out using your typical programming, and maybe using more pattern matching.
That's cool.
I guess it's seeing this whole template metaprogramming thing, which I'd use through C++. A lot of other languages have similar concepts. Seeing it through a different lens where we have all this established programming language design that allows you to approach it in a much more useful way and get a better design out of it.
And if you hadn't created Singeli, you would have been stuck doing what it does in the case of CBQN and C, and then maybe using its preprocessor. Since you guys aren't using C++ for that, you wouldn't have been using C++ templates.
Yeah, and we've written some preprocessor stuff. It only goes so far. The preprocessor is just awful even compared to all these other languages. If you need to do a test on some number, you have to do something like define test 1 to be something, define test 2 to be something, define test 3, which is 3 is the number you really want to be something else, define test 4 to be something. It's not a real programming language, and you want to do programming, and so you're really in trouble.
It's not really even a real macro language. And a little bit of a tangent. One of the things I find very impressive about BQN is the documentation. So do you like writing documentation? Because you seem to write a lot of it.
No.
You don't like it. It needed to be done for this language to the degree that you've done it.
Yeah, I mean, I don't really hate it. If you just want to write a description of what something does, that's okay. But at some point, it gets tiring, writing all the details and stuff. And you've missed something somewhere. Some of the diagrams were fun to do. When you've got a really nice diagram that explains what something does, it's very nice to have that and to see it and say, well, this really captured what I wanted. But the process of doing it is a little tedious.
Not only do you describe how the language works, but the thought process behind why it works the way it does.
That part is actually enjoyable.
You have a page describing all the things that you feel are problems in BQN, some of which you've actually fixed, and others that you say, this is a big thing to bite off, and this is why I think this is an issue. And that is a long page. You have really been honest about saying, this doesn't work so great, that doesn't work so great, this would be better here, that would be better here. Steve, I can't think of any other language where somebody's documented that. We are the creators of this language, and here are all the problems that we see with this language. Have you?
Your documentation is extremely good. When it comes to writing documentation, I need to make this some sense to the guy who's never seen this before.
And who might even not really have a good handle on the terminology.
That you've done really well. And going into your page, which I really loved, where you had all the different symbols.
Yeah, the key map page.
That's very helpful. You have a keyboard that more facilitates using BQN?
Not really. I just use the backslash prefixes. I don't even set up the global keyboard, which a lot of people use. I mean, the way I think about this is everybody complains, one, that all the symbols make BQN too short to even read it, and two, that the symbols are too hard to type. Well, no, if I type backslash in a letter, that's much easier than typing out the name of a built-in. So, I mean, I'm still coming out way ahead here. I spend more time thinking about my code than writing it, so I don't see a need to further improve that aspect because the backslash thing just works fast enough for me.
When you're typing the words in C or any language like that where you're just typing, are you going to be more motivated, just more typing because you can do it with the things you know that you've written rather than go and look back at what are the tools available, what one character or overstrike character can I use that does that whole thing? If you're going to write your code more efficiently because so much is happening with a single symbol rather than just this ability to do all this typing.
The whole point of the value of an autocomplete, it saves you from all the typing you would have to do to spell out the entire signature of the thing you're trying to call its long name and its names of parameters and all that sort of stuff. So is that a boon?
Well, I just use a text editor. There's this totally ridiculous notion that I have to call out that APL is a write-only language. No, everything about APL is optimized for reading. The way these array languages work is that you think very hard and you figure out, what's the perfect way to solve this problem. And then you write this little tiny expression that anybody who understands the language can actually read very quickly. And furthermore, they can run parts of it in their APL interpreter or BQN and see what the intermediate results are. It's actually a very good language for reading. Not all that great for writing, so...
the backslash commands. How does that work exactly?
It's built in on all the online stuff. So if you go to the main page, there's the REPL there, or it links to a dedicated one. In the REPL, if you type backslash and then most of the letters on the keyboard, you'll get some BQN character out. The idea being that backslash is not used in BQN at all. So people think these Unicode characters are problematic. The most problematic character in BQN, if I'd realized this, I would have searched harder for alternatives, is the backtick character, because that's what Markdown uses to indicate a code block.
The backtick on the keyboards I use, it's a really hard shift thing to get to.
Yeah, fortunately, it's not like super common, so it's the scan operator, but it gets used a lot. Not only it's a special character in Markdown, but also if you're going to escape it, all the Markdown systems use different ways to do that. I wish I'd used a fancy Unicode character for that.
It's great that one modifiers are always superscripts and two modifiers are always the little circular glyphs. I found it kind of harder to read because it's not as straightforward as the slash.
They are kind of hard to tell apart. The tilde and the double forward ticker are annoying too. The annoyance is just that you don't have a lot of options in Unicode for what you can choose for these. There are a lot of things that I would have done in some different way if the right character existed.
Back to the page of here are the things that Marshall, creator of BQN, think are wrong with the language.
Well, I mean, not strictly wrong. Here are the difficulties that the language presents, and I think, in fact, the majority of them can't be solved without changing the language so much that it just renders them inapplicable. So, I mean, that's not really solving the problem. That's dodging it by moving to a different paradigm.
How do you feel about writing something like that, though, where the community's arguing about the various virtues, liabilities and benefits of languages? There seems to be a lot of value in that because you could end arguments.
Yeah, I was going to say it actually makes it a lot more comfortable when somebody brings up a problem. I say, yes, I've noted this problem. Here's the link to the section.
Exactly.
Sometimes that section includes, what the programmer can do about it if there's like something that works in the language. One that comes up a fair amount is how do I turn a function, something that's syntactically a function role, into a subject so that I can pass it into other functions? And the section on that says, well, there's no particularly good way, but here's the 3 or so ways that are okay for it. It's rare to, collect all the grievances in one page, but I think it's not that rare for language designers to be honest about the trade-offs of their language and say, this language is for this particular purpose. We don't try to handle this other thing, and here's the problems you get. Or give, reflections on what worked and what didn't. Although that's usually after a longer period of time, saying, I worked on this language in the past, and here's kind of what I learned. So I don't think it's totally unique, but I haven't seen that particular format, no.
Do you mostly work alone? I guess you and Zyma are kind of a team on Singeli and CBQN.
We work alone in coordination.
Is that how you like to do the things you do?
Yeah, particularly for this language implementation. The problems, they have this particular, mathematical kind of hardness where you just really need to wrap your head around the problem and think for a while. Collaboration does not really make. You can get new ideas from collaboration, but you can't get that insight that you need to develop new algorithms or anything that way. I don't even know what working with someone else on a problem like that would even look like. I mean, I guess you kind of throw ideas back and forth, but the solution comes from you thinking internally in your own head. There's only a certain level of collaboration that's even possible. And I think at times, Simon and I have done this thing where we discuss what are the possible approaches to some particular problem. But more often, we see something that looks vulnerable, and then we go take it off on our own and butcher it, and then report on what exactly happened.
How long were you developing BQN while you were at Dyalog?
There is a page on this. There's the history of BQN's development. There were several stages. The first time this idea of making something like APL, but improving it, came up was in our Young APLers group. I publicly announced BQN in maybe it was May, and that was started about 6 months before. So we had just started this Young APLers group where the younger members of Dyalog would meet up and talk about stuff, and that was one of the topics. Before that, we created the APL wiki, so that was a pretty good accomplishment. And then we decided to just discuss hypothetically what we'd do if we didn't have all these backward compatibility requirements with Dyalog, if we were going to make a new language, which had been attempted before at Dyalog. That was APL Sharp, which was heavily predicated on the C# ecosystem and Silverlight too. Microsoft killed off that attempt.
Really? APL hashmark, APL Sharp.
Yeah. to be parallel to C#. And Dyalog still has some pretty close ties to C#. Its object model is really based on C#'s model. They used APL Sharp as like an opportunity to rethink the language, and there were some pretty good ideas in it. But it was tied into some particular stuff on the direction of, where Microsoft is going, and then Microsoft turned in a different direction. Although, on the other hand, that was what gave them the opportunity to work on a new language at all. If that didn't exist, they just wouldn't have tried, because getting somebody to adopt a new language merely because it's a better programming language is really pretty futile.
To that point, how much do you think about adoption as a factor in the design of I, BQN, and Singeli? Does it matter?
Well, I absolutely none. So the reason I named it I was partly because it's an absolutely terrible name for a programming language. And I figured I'll use this up for a programming language that nobody actually wants to use, and then nobody has to suffer the indignity of having their programming language be named I after this, because it's already been done. Somebody else has, of course, named their programming language I since then.
Every letter probably has several different language implementations somewhere in the world.
Yeah, there's at least one page that collects like single letter languages. There's one that links to I, and there might be others that don't link to I. Choosing a single letter is just not a practical decision. So
You and Zyme are pretty active in the BQN channel in Discord.
yeah,
It's nice.
with respect to the adoption, at this point, I would still like BQN to have more users, but not by too much. Adoption has positives and negatives. I'd really like users that are able to advance the language in some way, that are thoughtful, that discover new ways to use BQN features or implement libraries in the language that are useful, do good stuff. I don't just want people using BQN just so people are using my language. And I definitely don't want people who are going to come in and complain about how the language is and not really make a serious attempt to learn it, which is kind of the first level of the language learning funnel.
Do you get that in the Discord channel there?
Yeah, sometimes. I think it's better than it's been in the past. BQN no longer is this shiny new language, and so there's not really any hype around it, and it's a known factor. And so people don't come in just like expecting the world and saying, well, you're going to cure cancer for me, right? The level of expectations that people have for new programming language are actually unreasonable to this degree, I would say, because people think that a programming language that's nice to write in is going to suddenly revolutionize computing and make computers do things that computers can't even do. Computers can process your information for you, but they can't make your life better.
They can't?
Only to the extent that processing information makes your life better.
It's the solution to the problem that can make your life better.
Yeah, they're not going to fix your corporate structure at work where your manager doesn't understand what you're doing. And a programming language is for programming, and maybe it's better or worse. It's not going to fix all your problems in programming. Even the perfect programming language would present difficulties for using it.
So do you get people in BQN where they're unhappy that it's not one size fits all and will solve all problems?
Yeah, well, of course, all these people bounce out after some fairly short period of time. So in terms of the motivation, I would say, no, BQN is not designed to be domain specific. I mean, it's designed to be approach specific. It's designed to reward you for using array programming, to make that be easier, and particularly since arrays are immutable, which is very important. Things that you would do with mutable arrays, you can't really do. Just using immutable arrays does not limit you to a particular domain. Some algorithms are going to be harder in BQN, but then the algorithms are not really that big of a part of programming anyway. So it's designed to be usable for anything. Well, maybe with the exception of it's not like a systems level language. It's not designed to work very closely with the hardware or anything like that. We prioritize, making things easy over making them able to handle the niche details of this particular operating system. Right now, I don't think our system you have to use for working with files where the name is invalid Unicode. I'm not sure if we can do that at all.
Do you feel that Singeli might fit that niche of system programming?
Definitely of low-level programming. There are some aspects of system programming, like working with the operating system, where Singeli is able to do that just by kind of delegating it to C and saying, well, you're compiling to C, or at least you can compile to C, so you can call some C functions to work with it. But right now, it doesn't have a good way of handling C structs. If you've got a bunch of functions that are going to return structs, then there are kind of workarounds where you can have the write the struct to memory and then give Singeli the pointer, and then you access specific bytes from that pointer, but that's no way to program.
OS API calls, it's not ideal for that sort of thing.
It's designed for, you might say, machine level programming, which is I know what instructions I want to call, and I want to write the code to call them. Or I have a general scheme of what instructions I want to call for different types, and I want to have a function that's generic over all these types. And so I want to be able to do this without having to hand write 10 different assembly functions. I want to instead specify the whole scheme of, if you have this type, then you need to do this step here, and so on. So it's designed for scaling machine level programming in a particular way. If plain C is good for it, then you can do it in Singeli, but you're not really benefiting. I mean, maybe you'll get, like, Singeli is a lot stricter about type conversion, so you won't have to deal with, in C, what happens when I convert an unsigned 8-bit int to a signed 32-bit int. But maybe I should say Singeli is not going to give you anything over Zig, where these questions have actually been considered and thought out in some reasonable way. The problem with C is that C is not very good at the things that people use it for. It's just that very few other things are better.
That's funny.
C is domain specific. It was originally written for creating device drivers in Unix.
Or creating Unix itself.
Yeah.
Well, I'd actually argue that a major influence on early C was to make it easiest to write a compiler for new machines. The modern approach to portability really did not exist at that time. Now it's pretty clear that if you're going to design a low-level language, the width of a type should be independent of what it's going to be run on. In a small number of cases, maybe you want to pick a type that's sized based on your CPU, but usually you want to write I32 and get a 32-bit signed integer.
Yeah.
And the operations defined, like C shifts were for a long time, or well, even now, I think C++ fixed it and C didn't. Like signed shifts to the right are undefined behavior because, maybe the machine doesn't use 2's complement. We recognize now that we write programs that are intended to run on many machines. We have adopted the idea that the specification of the language should not depend on where it's going to be run, because nobody writes programs to be run on a specific CPU and knows all the details of that CPU and tailors their program to that.
Certainly not in general consumption. That's true.
It's funny you say that now we have that awareness.
I think there were plenty of people at the time that C was designed that also developed programs that way, but they didn't design C. So there you have it. I think it's also fair to say when you might be working with an 8-bit or a 16-bit or a 32-bit processor, it matters much more what the register size is. And these are so slow that performance is a huge deal. You really need to have those be working on one register. And, if you say everything's int32, your program is going to get at least 4 times slower. So then it makes sense that you care. And now we're in, the era of 32-bit and 64-bit, almost all 64-bit processors outside of the embedded world. And so that just matters a lot less. Basically, the processors have stepped up to be able to support this machine-independent programming model. You can understand how C got to that point where it is. It's really surprising how few languages do this, and Singeli is one of them. Try to make a model that's both purely low level so that you know that, if possible, one operation is going to run as one CPU instruction and also is machine independent. Just those two factors cover a whole lot of the usage of C, and very few people have attempted to do this, and that's one reason why C remains the go-to language for this, and why we made CBQN and C, because C++ and Rust and all this have a different model of programming. They're trying to add higher level abstractions and stuff, as opposed to give you access to the CPU. When you really need top speed, all this safety is going to prevent you from getting top speed, and so eventually you'll just have to work around it in order to get the best possible performance, which is not really necessary. I will definitely admit that CBQN goes well beyond any reasonable standard of what it should be doing in terms of performance. But if you want the fastest operations, you really do have to have this low-level language, and there are not a lot of options for that.
I think Zig is really focused on some similar sorts of guardrails that Rust has, but we're not going to force them on you because there are instances in which they would get in the way in terms of performance.
The Rust memory safety mechanism ultimately comes down to inserting runtime checks.
Yeah.
If you run into that runtime check and you're a programming language implementation, that your programming language is broken, it's unusable. So you need to be testing well enough that you're not relying on these checks. And at the point where you have that much testing, the runtime checks are not actually necessary. There's nothing really that they help you to do. I guess in some instances, it's kind of hard to tell when the program that I wrote trashes the memory in BQN what exactly caused that. but I know that it's just broken. And having a runtime check, it would save me a tiny bit of time testing that. The end product that I have, it needs to not rely on those. If there were a language that could prove all of my algorithms were not actually going to write outside of memory, that would be great. But some of these use pretty complicated index orders. Most of them are for loops, but the ones that aren't are often going through the array in some transpose order or something, and the bound is kind of hard to prove. For those, a system that would prove that it's correct would be a whole proof system for a programming language. And Rust does not have that, and no serious production language. I guess there are proof systems that come close to being serious production things, but nothing that's used like in bulk to write programming languages does that level of proof. So if you say, well, my language is memory safe because if the implementation of the language is broken and tries to trash your memory, it errors, that's not value to me.
There are quite a few language implementations out there that are relying on Rust. I'm not trying to argue with you, but you've got Rock, you've got Weewa.
It's not bad to use Rust. With BQN, it's a very simple language, and so we're at a stage where we have long ago implemented all the primitives and done them fully correct. What we're trying to do now is make them many times faster, use the vector instructions that you have on your CPU. And I don't know if there is a programming language that's improving primitives to the extent that we are. We want the absolute maximum performance of if you're going to transpose this array, the language needs to do it as fast as possible. There are not many languages that try to implement their primitives at that level.
They probably rely on scalability on GPU or something like that to solve the problem.
Well, no, the simple fact is that the computer is fast enough. Like you can do things 100 times slower than you need to, and your program will finish in the blink of an eye for most programs you write.
That's true. Unless you're making way too many API calls, calling API calls, calling API calls, calling API calls. I mean, that's what most mobile apps are doing. The problem that they're solving shouldn't take that much effort, and yet they're going through so many layers that you have lag on these incredibly powerful devices. It's kind of horrible.
BQN probably wouldn't even save you from that. If you're having all these layers of abstraction to make things nicer for yourself, the only solution to that is to have a different method that uses less abstraction. It's definitely fine to design a user-level program, the thing that's actually going to be run, using whatever frameworks for convenience you want. It's not good to design a framework that way. Hopefully, the people who design frameworks would eventually really optimize how the framework's written.
I don't think that's their motive.
You just have your one layer framework that you use in its reasonable way. But of course, this is not really what happens. People build frameworks on frameworks and they lose performance that way. But with BQN, we're just saying we want the BQN layer to run its primitives as fast as possible. And also that it optimizes your array types. Like JavaScript, if you have an array of floats, that's just floats, no matter how much JIT compiling it's doing, partly because JavaScript distinguishes between the 0 and the -0. So we have to get rid of that distinction in BQN to use integer optimization. Semantically, we're like JavaScript. We only have floats, except for this 0 -0 thing. But if it's integer valued, if it fits into 8 or 16-bit or 32-bit ints, we will try to collapse it to that size. Or we try to never actually get up to needing floats, is probably a better description.
Okay.
And then once you have elements represented as 1-byte ints or whatever, well, firstly, the typical implementation's using for loops. Like if you're going to say sum each row of this array, and the array has rank 2 and you do it using a nested for loop, when the width is small, that just really crashes and burns. Even if you're doing a sum, this is something that a C compiler can handle because it knows how to vectorize this. But if you're summing each row, this is too complicated for a C compiler to handle. It's only going to vectorize to the bottom level on the rows. And so if the rows are short, then a row doesn't even fit in a full vector. So this is the sort of problem that we need to handle in CPQN. Primitives exposed to us directly. So we're in a really different position from a C compiler author whose user's written all this scalar code and they need to then synthesize that into an array program. For us, the user hands us an array program directly and says, implement this in the fastest way possible. So we're presented with all these problems where we have 1, a small type, and 2, all these complicated array structures, and 3, a simple enough operation on them that we can actually understand it. This is what makes it the best path for better BQN performance, at least if the user knows to write array code, is that we implement some pretty fancy algorithms and use a lot of vector instructions within each primitive itself. Most languages don't allow their implementers to really take this approach for various reasons.
I definitely recognize the performance you're putting into BQN. It's one of the main reasons I'm motivated to use it for our engine, for Proglang base. Steve doesn't like this so much. I've started using it to replace bash scripts. I'd made a patch to my fork where I could turn off the piping so that I get the display immediately as it's executing OS commands.
So that's just for outputting text from BQN? Yeah. We actually do have a system function for enabling raw mode in the terminal because some people were using it for like terminal games that need to be interactive, or not necessarily games, but things where you input a character and it needs to basically draw stuff in the terminal.
Well, I had to use that for BBHW to keep it from doing the line feed when it's outputting the seconds, right?
Oh, yeah.
The fact that you implement it in C is actually very appealing because the ability to go from source with the minimal tooling to get to that implementation. And BQN has been one of the ones that's been successfully easy on each platform, Mac, Linux, and Windows WSL, with just the straight up GCC or Clang.
Yeah. I'm thinking probably one of the challenges with Singeli is if somebody who's not associated with BQN opens up the Singeli page, they see, well, Singeli is implemented in BQN. You have to install BQN in order to run Singeli. Of course, I'm not going to try to hide that. But then they probably think, oh man, I have to install another language. This is going to be a huge hassle.
Or you can just build it.
I mean, yeah, if they're on Linux, then clone and make is definitely going to work. I think this is probably a big turnoff for people not getting into BQN, but getting into Singeli. Any serious low-level programmer, which there are not really many of those to start with, they're not going to care about BQN. They're not going to have any interest in this language, and quite reasonably, because it just doesn't connect to their work. So yeah, they're going to say, what are these crazy people doing? They implemented this in some random array language.
Are you still interested to continue to do work into the future in programming languages? Do you have other interests you want to investigate?
Well, I don't think I'm going to make anything else like BQN again. I am still interested in programming languages, although more like academically, because BQN is now a language that works for me at a scripting language level. So it's kind of what I like to use. Other languages could be a lot better, but I don't think that would be in a way that really affects the way that I program that much. Because fundamentally, if I want to program something, I know how to program it in BQN. And then the actual time spent fighting the language is very small compared to figuring out what I wanted to program in the first place. So, I mean, I've always got ideas about how better designs for programming languages might work, but I don't have that immediate motivation of actually wanting a programming language to do something. I think there's a lot more work to continue to do in Singeli, and there's always more stuff in BQN. So one thing that I might start with in BQN is to start actually compiling our source code more and do compiler optimizations on the source code and start looking at combinations of multiple primitives and in terms of other optimizations like throw out dead code, or if there's a repeated sub-expression, combine those, or even do array compilation. And I have a page on why scalar compilation for array languages is not that great of an idea. But the short thing is that we have all these primitive implementations that are much better than a scalar compiler can hope to do by looking at things from a scalar perspective, because we've developed algorithms by thinking about what the array operations are actually doing and how to approach that, how to translate that to vector instructions. So another thing might be to try to make a compiler that actually works with array operations and doesn't get all the way down to the scalar level. Instead, looks at the vector implementations of these operations and tries to fuse them together, particularly for arithmetic, which is also the easiest thing to compile. That's a really big difference between having your plus read from both argument arrays and write to the result array versus being part of a fused operation where it takes whatever register was output by the previous primitive and outputs another register. And those are all fused together, and together they loop over some argument array and output. That can be maybe factor of 5 difference for fusing particular, not for a whole program. You never get that for a whole program, but in the best case, if you had multiple operations. That's what I'm guessing is the kind of speed up you'd get on like heavy arithmetic and stuff.
It sounds like you're always thinking about performance.
That's the area where there's the most ongoing work. And there are still design problems in BQN, but I mean, mostly it's in like system functions and stuff. Really, the way these should be approached is to grow out of existing applications. There's this whole class of applications that all need to do, this whatever web interface thing. And then eventually somebody builds a library to do this. And then ideally through multiple libraries, we figured out finally what a good way to approach this task is. And then we're going to anoint a system function that's going to handle it because we figured out the design. Without all that usage and people taking their own approaches and figuring out how they want to structure their utilities, it's pretty hard to move forward confidently on new system functions if it's not like a domain you're really familiar with. So in that way, the design of BQN is kind of waiting on more users, is how I think about it. And the design of Singeli is sort of different. Fundamentally, there's not that much that we want to do with it. Like one big future problem is working with structs, bringing at a still very low level, more higher level programming into Singeli. Fundamentally, the model in Singeli is just that you have memory which has some stuff in it. You're able to create variables and write values to them, and you're able to ask the CPU to do something. It's really a very simple language. And I mean, the whole implementation is maybe 2,000 lines of BQN or something like that. You just can't specify a complicated language in that much code, and it's not particularly dense BQN.
Only 2,000 lines? That can't be a serious thing.
Yeah.
It's got to be in the millions lines of code.
It's compiling to C, so it's not an optimizing compiler or anything. The question was, you're always focused on performance, that I guess I'd say that's the area that throws a dead end up in front of you the least often. Whereas designing features, really, it's not something that you can just work on steadily, because you need to have the experience with the applications that you're designing for.
That makes sense. Performance is always something you can just continue to improve upon and polish. That would make it fun.
Yeah.
The naming, your original idea was to add one letter to APL.
The way I did this was better than reality.
Adam made a nice point, as he said, it's the first 3 digits of factorial added to APL. Then you end up with BQN. I thought, well, that's really clever, but that's not what you thought about originally, right?
No, I just attempted to add 1.
That would have been very mathematical. So you should stick to that story.
Yeah, I agree. That's a history edit that needs to be maintained.
Well, one of the problems is that BQN actually removes APL's factorial primitive.
Well, oh yeah, that's a good point.
Because it's not a generally useful utility. We do have system math.fact, but we do not have the exclamation mark. The exclamation mark is assert.
What about Singeli? How did you come up with that name?
It's got a lot of parallels, so it's cool. There's a Tanzanian genre of dance music that I very much enjoy called Singeli. So that's where the name comes from.
Oh, that's great. I like that.
I made the connection largely because it's designed for working with SIMD, which is single instruction, multiple data. And it just sounds so similar. But there are also all sorts of other parallels. Singeli music, the one defining feature is that it's very fast. There's 2 major tempos, one that's around 190 that's used a lot, and then there's another that's just short of 240. It's like 235 beats a minute.
So how do you dance to that tempo?
Yeah, so the DJs will brag about how no one can dance all night to their music. It's wild. You can look up videos on YouTube of Singeli festivals, and I mean, there's a sea of people. The way they approach music in Africa is worlds different from the way we do here. I mean, they just have so much enthusiasm for it. It's something that has to be seen.
You have a band camp. I've listened to some of your music. I guess you've played guitar on some earlier stuff.
Yeah. I'm working on a recorded album that should be out within a few months. It takes forever to record things. I can't play without mistakes. So
just go jazz, man. Mistakes are part of the game.
Well, there are many mistakes in my recorded material.
You have an entire album generated by BQN code on your Bandcamp.
Well, with 2 recorded bass lines.
My favorite song title is the I Lied.
Songs I won't write drum tracks.
Yeah, I won't run drum tracks for anything on here. And it's like track 1, track 2, track 3, track 4, I lied. And that one's got a drum track on it.
Yep.
That was a good joke.
I just went back and listened to that album, and it was better than I remembered.
I liked it.
1, it's got mistakes in it, and 2, I edited by like splicing takes together. In my first album, I would like edit individual notes, and I didn't do that for the second one. I just took sections. Now with the recording, I'm trying to do single takes and actually have a decent performance, and I'm pretty close on most of my songs, but it just takes a while.
So tell us how playing music fits into your life.
Well, I spend a lot of time playing music. I play the piano, which I started a few years ago. Learning classical piano, I play that for like an hour a day. And I spend a little more than an hour since I started recording this album a few months back. And I also play the clarinet from time to time, just improvising on that.
Anything else? Drums?
Well, and the bass. I don't play the drums. I program them all in BQN now. I used to program in them in J. And I played the Guitar Hero drums a while back. I have the understanding of how you move your hands, but I mean, I was never great at that. So piano is definitely the hardest instrument I play. Clarinet's so easy because you don't even have to worry about chords there. It's all just melody. I guess some people have trouble with the fingerings, but I think it's just so much easier to just think about one note at a time. I'm really not good at multitasking, so piano, you definitely want your left hand and your right hand doing different things. I mean, I'm not gonna claim that I'm a great clarinetist, that's probably my weakest instrument, but it's also the one that I find the easiest to make progress with.
Music's an important part of your life,
Yeah.
but not more than creating programming languages. If you had to give one
Um,
up, which would you give
I
up?
don't know. Does that retroactively take back all my programming languages? Because that's pretty tough.
You start now, you can pick one or the other.
Oh, yeah, I'd give up creating programming languages because 'cause I've already made the good ones.
I think most musicians would feel the same way.
Most of my programming work is still on implementing programming languages, and some occasionally on music. At this point, it's almost more like I'm implementing the languages to have something to do with my languages that I've implemented than to have them be implemented.
Want to say more about yourself or the other things that you're interested in, like music and 200, 300 beats per minute dancing?
Well, I've not actually tried to dance to Singeli. I just listen and bob my head.
You said it's a dance music, though. That's the primary thing, right?
Yeah, but I listen to all sorts of dance music without dancing. I'm very good at not dancing.
I noticed you got a lot of experience in both the object oriented and the functional world. And if you would agree with the statement that OO has value in places where functional does not, and vice versa.
There's some overlap, but they largely address different things. You can take a very object-oriented approach to functional programming. The core idea of object-oriented programming is this encapsulation. Message passing is a whole different paradigm, if you're wondering about that. If you think in things in object-oriented terms enough to get this idea of encapsulation really well, then you can apply that and make your program easier to understand in all sorts of different paradigms. If you understand this thing inherently is its own object, and the rest of the world doesn't need to know about all the internals, it only needs to know A, B, and C about this object and be able to call these three functions. And you write it to make it clear what's just its own thing that it's got going on and what it needs to provide to the outside world. I think that's really valuable, but it also has absolutely nothing to do with what you get out of functional programming. And it depends on what you think functional programming is exactly. Instead of maybe passing around data all the time, you could pass just a function that does what you want to do. That's pretty complementary to object-oriented programming. It works very well with encapsulation because you say one of the things that I provide to the outside world is this function, and actually one of the things that the outside world might provide to me is this other function. So yeah, I think they work very well together. I said Singeli is more of an object-oriented design, but that's at the higher level. At the lower level, it uses a lot of functions. So the parser is a recursive descent parser. There's this function when that takes a list of one Boolean and one function. And depending on the Boolean, it either runs the function. And so the function would be an element of syntax. So it says, when you see an opening brace, parse a block here. So yeah, I agree. They're useful for very different reasons. It's good to know both, and you can apply them both. The best thing for programming is to understand the ideas behind both and be able to apply them, whether or not you are actually writing in a functional or object-oriented style. I think immutability is a pretty important point. Everybody thinks APL is about the symbols, but I think it's about arrays being immutable. That forces you to work on, instead of one element of an array at a time and saying, well, I'm going to put this value there and that value there, you have to think about the entire array as a thing in itself. Using immutable things whenever you can get away with it is really the best approach, because when you have your object here and something else mutates it over there, it can cause bugs just from being unexpected, but it's also pretty hard to refactor the code and so on, because you can't easily find what affects what. On the other hand, there are definitely people who go overboard with the immutability. Lots of people say, I have this weird scan fold thing and I want to write it with just tacit code. And for a lot of these, I say, well, what I would do is define an accumulator variable here and then run this very simple fold that modifies the accumulator. And then at the end, you've got this modified variable out and you've got whatever the result of the fold is. I also kind of think when you have particularly these complicated traversals across arrays, and this is also a very weak form of immutability where you've just got one variable that's a local variable that you're modifying. Many problems are most naturally expressed in terms of immutability. If you are programming in BQN and you think, gosh, I have my immutable data, but I really wish it was a Haskell monad so I could best express modifications to the structure ongoing as a feature of time. The way that BQN provides this functionality is called mutable programming. It's not the most sophisticated structure you could possibly have, but it's a very nice structure for representing changes to state that are ongoing as the program goes, and you should use it. Yeah, in some cases, maybe a more sophisticated functional structure would capture some mutable pattern, but there's also trade-offs as you try to go deeper and deeper into forcing immutability onto everything.
Is there any performance hit to the mutability of arrays over being able to manipulate arrays in place?
Yes, but fundamentally, with immutable arrays, you need to be writing different code. Like most data manipulation is actually just a perfect fit for immutable arrays. Generally, most of the work you would be doing is in a truly imperative style. Create this new array and do a for loop to fill what its values are. I mean, I guess if you can keep modifying an array in place, you use less memory, but you're usually not going to be memory bound anyway if your arrays aren't so huge they don't fit in the cache. There are performance benefits to working with mutable arrays, but it comes with a sort of restrictive view of performance too, because this whole system of having an array and modifying places in it, from a CPU perspective, working with memory in this way is not very fast. What you really want to do is be able to express algorithms at a high enough level that the language can optimize them. What I found with BQN is really that C is not actually very good at optimizing programs because you specify programs in this scalar language that has no knowledge of all this vector functionality on the CPU. And the vector functionality is a much better fit for array languages. People kind of see the mutable model as the default in terms of performance. Then they look at the places where you're losing performance relative to when you go to immutable data, and they say, well, clearly this is a worse model for performance. We choose it for these other reasons, but nobody would choose immutable data for performance. But in fact, in a lot of other ways, the immutable model, and particularly with array programming operations, is a lot faster.
Especially those that can take advantage of those vector operations in the chip.
Taking advantage of them is a matter of the implementation. Fundamentally, the operations, and I can't really give an explanation for why this is, but they are fundamentally a good fit for parallel processing and vector processing and so on. Even though there are things that I haven't implemented in vector instructions, I can tell that a certain operation fits in the domain of array operations. And it almost always then turns out that it has this nice CPU implementation that fits very well with modern hardware. It's pretty hard to take advantage of all of that, but it's there. And so this mutable model, it's kind of a dead end in terms of read one thing, do some computation, write one thing. It's a very flexible model that can express all sorts of things. And it can express some things that could be implemented very quickly. And C tries to do this with the autovectorizer. But it can also express all sorts of things that just don't have a fast implementation. Array programming is much less like that. All these array programming operations turned out to have fast implementations. It's more limited in terms of how you can write programs. You have to do more work to write something in a style that uses large arrays. But if you're able to do that, then the implementation can make much better use of the fact that you've written an algorithm in this way. There's a higher performance ceiling on, how fast it can ultimately process data.
In the domains that I work in, most of the time mutation we're talking about is a mutation of trees, the mutations of nested structures, which are not regularly shaped data structures. A structure of structures of structures of structures is usually a bunch of pointers to other structures on the heap somewhere else on the heap. And then in an OO paradigm, you're talking about a network of objects that all expose some externally observable state to each other. Except in the case of Proglang base, because we're looking at a matrix, it can very much be expressed in a regularly shaped array.
I think the old school array languages did not share data. If you wrote A gets B, it would copy that array, and then you were free to mutate arrays whenever you wanted. But eventually they figured out that you really want to copy those references. And what they did was started using reference counts so that you can say, well, this array has a reference count of 1, so I can mutate it. That's how you can often get mutable performance in CBQN. If you've got some array, you can even do like an object wrapper around an array that provides, say, a read element at this index and mutate element at this index, plus all the interpreter overhead that maybe someday we could optimize out. But currently, you'll get the asymptotic performance of mutable arrays, at least, where writing a single value does not have to copy that underlying array.
Instead of saying, well, I'm going to take a performance hit because I'm taking all these copies all the time of the arrays, you're going to code it differently because you're working in that immutable environment.
Yeah. It can happen that the straightforward approach in an array language ends up faster than the straightforward approach in C, especially for small problems. One that came up on our forum was somebody said, I solved this leak code problem. It's probably not the fastest thing, but here's what I had. And the problem, I think, was you're given an array of heights and figure out if it rains on something with these heights, how much rain would be trapped in a kind of one-dimensional model. What you want to do is find the highest values going in one direction and in the other direction. You can see those are the points that trap water. And you can see how much lower than that the actual height at each position is. And so they wrote, a forward scan and a backward scan with max and min. And I ran this and it was fast because we have good scan implementations. And I said, this is going to be much faster than the way people write it in C. You could translate the max and min operation into C, and then it wouldn't be fast because C compilers, for some crazy reason, don't vectorize their scans. I still don't get this. The optimized C solutions that you could see on LeetCode were all optimizing for memory use, which is, in most cases, just totally irrelevant to performance. They were performing all these branching checks and things, getting it down to where you only visited each point once. But it was doing such complicated stuff. I didn't time it, but I knew it was going to be much slower than the BQN implementation because BQN was doing less than a nanosecond per element, and you just can't get that fast with scalar C code. People always ask, what are you giving up by moving from C to BQN? But if you turn this around and say, what are you giving up by moving from BQN to C? Well, I had this perfectly simple solution to this problem, and it worked great at a super fast speed. And then I go to C, and there's simply no way to get this performance. Who would program in C?
Most of my work is in business data processing. It's not a lot with data mining.
We're not really doing data mining, though. We're actually creating the data, and we can create it in whatever shape and model we want.
So data minelaying. So all your problems are what you have put in the ground.
The point that you were making, Marshall, about somebody saying, I can write this in C, why would I go to BQN with these symbols or whatever when C will do the job? The minute I started converting bash scripts to BQN, I immediately saw, just the parsing of strings and putting separators in or finding separators or doing things like that. These primitives are very nice for that.
Strings are something that's traditionally been immutable.
For me, the whole tricky part from going to C to BQN is the same as going from C to APL. It's just the symbology. Once I had the symbology down, where I really understood where they were and how to use them, I would probably look at it and go, oh no, I never want to go back to C. I can write the same thing in 100th the size in BQN.
Finding your way around the symbols is probably easier than you think. Learning what each one does is one thing, but learning how to use them is a different thing. You have to have that mapping from what you want to do to which primitives accomplish it. And that is actually pretty hard to learn. I think that more than the symbols is the big barrier to the array paradigm. Symbols probably matter less than you think.
All programmers are comfortable with symbols. You can't look at any C-based language without having to know what the open brace and the closed brace do and what the equal sign does. There's some level of symbols in there, and then at some point somebody says, okay, this is a bridge too far. There's too many symbols. There's not enough words. And I think that's more familiarity than anything else.
Oh yeah, it's totally. When people say special characters, they don't mean the ampersand and the @ sign, but instead they mean like the slash with a bar through it. Well, which one of those is really a weird character? I'm looking at my keyboard here, and I've got the hash mark and the percent and the dollar sign. None of these are like nice, clean symbols. They're all just these weird things that were drawn out for a specific purpose, and we use them for different things.
So you guys aren't planning on doing a Rust implementation of BQN or Singeli anytime soon, right?
Well, it's funny because Zyma has just spent a ton of time on doing an LSP implementation for Singeli, so the language server protocol, maybe. That's the thing that powers all the editor functionality in newer editors like VS Code. And that's in Rust. So he made a whole Singeli parser in Rust. I think just because that's the language with the best support for LSP stuff, or maybe it's the one that integrates with editors best or something like that. So we have a parser now. I've been kind of thinking about doing self-hosted Singeli and Singeli, but I think that would probably be a lot of work. And like I said, Singeli has no structs or anything, so a lot of the higher level would probably need additions made to the Singeli language to really make it convenient to do. The thing is, Singeli doesn't need to be that fast because all it's doing is compiling your program to this intermediate representation. Like running an interpreted program, but pretty much every step in the interpreted program gives you an instruction in your output program. So how many instructions are you really going to have in your output program? You need a whole lot before it takes really very long to compile this thing. I guess there are cases where you might be doing a complicated computation to get one of your pre-computed arrays, and then we want it to be fast. But the fact that it's in BQN actually helps a lot with that because the Singeli primitives are secretly BQN primitives. So we have a pretty decent implementation for those that's backing it up.
I like how much it's bootstrapped.
I have bqn.bqn, which is a BQN interpreter that's implemented using the self-hosted compiler and runtime, and then only BQN sources beyond that. It's a BQN program that can reasonably be said to re-implement BQN. Of course, we also have the system value system BQN, which executes a string as BQN, but you can't just look at the source code system BQN and see what the definition of the BQN language is, as opposed to in bqn.bqn. A small number of things that are just the same, like selecting element at index I from a list. You have to rely on the interpreter for some things. But if you know what those are, then everything beyond that is implemented in BQN. So like the whole VM is a BQN program. So if you read this BQN program, you would understand how the BQN language works. And this program could be ported to another language without much difficulty.
The demand for BQN, Singeli, and things you're doing will increase. I think there's a lot of value there. It's definitely a viable candidate for replacing shell for shell scripting.
Oh, huh. Yeah, I didn't think about that.
Even Python is too heavyweight.
Because there's a fair amount of startup time and stuff.
BQN feels like a good fit, and I like programming in it, the look of it, the feel of it, of what I've done so far. I haven't gone super deep yet, but I've committed that our internal data engine for Proglang base so far, BQN.
In terms of the future outlook, BQN's kind of past this shiny new language. The interest from new people definitely did drop off. A lot of people are on the forum for a particular period when they're working on something, and then they leave the forum, and I don't know if that's because they got what they were looking for and they're happy with BQN now and they're still using it, or if they just lost interest in the language. But I can say that we still have new people coming in who are interested and people with ongoing usage. So I think it's clear that it's going to survive in some form as a living language as opposed to just something that nobody ever really picks up. It's definitely got some future, and I'm pretty fine with that future being a smaller niche thing. Singeli, 99% of programmers don't need to do this sort of low-level programming. The market's small, and the people who do this really don't seem interested. Most of them are using C intrinsics for everything, which you program into this and you can just feel that they're working against you every step of the way. Most programming languages, it's like, oh, well, I have to use this thing. C intrinsics actually slows me down by multiple factors, just having to have my program written out with these unreadable intrinsics. If the programmers doing high performance work haven't moved away from that, then I think there's, very little motivation to look to new languages. So Singeli, I mean, it might just stay the thing that is used to implement BQN, which it's pretty successful at that, so that's all right too. But I personally don't expect many people coming to it.
Most importantly, you enjoy programming in it. You get to code in what feels good to you.
I think I've gotten much more done in the same amount of time with having Singeli available.
Yeah, sounds good. Well, we appreciate you coming.
Yeah.
Yeah, thanks for the invitation.
And we'll happily talk to you again in the future.
Look forward to seeing you again on the Arraycast.
Or hearing you. We don't never see him on the Arraycast.
Audio only, that's right.
People will get to see you on this, though.
Thanks, Marshall.
Yep.
See you guys.
And goodbye.